Good morning everyone. Today we are going to discuss about the protective relay terms and definitions. In the previous classes we discussed about what is a protective relay, what are the classifications, how it works and all. Now we go for what are the various terminologies used in protective relay. First of all, we have to know what is a protective relay. First one is, what is a relay? What is a relay? A relay is a piece of apparatus which detect the fault and initiate the circuit breaker operation is called a relay. Whenever it reaches a predetermined value or preset value of activating quantity, the activating quantity may be current, voltage or whatever. The activating quantity, whenever it reaches the relay coil, trips the circuit breaker by giving a signal. That means it is electrical relay when it closes contacts. These contacts will be closed when a predetermined value is reached by activating quantity. The activating quantity means a current, voltage, power, direction or impedance Z, like that. These are the various quantities that can be considered. In overcurrent relay, activating quantity is current I. Are you understand this? In overcurrent relay, activating quantity is current I. In over directional relay, the current direction is the activating quantity. If the direction is reversed, the power reversed, then the relay will operate. Now we go for a relay. We discussed what is a protective relay. It is electrical relay which closes its contacts when activating quantity reached to certain preset value. That means preset value is given. For any relay, 10 amps is the relay current, assume that. For 10 amps, if it reaches to more than 10 amps or greater than or equal to 10 amps, then the relay will close the contacts of circuit breaker. That means a relay gives the signal to the circuit breaker. In the previous classes, we discussed about what are the protective relay, overcurrent relay. By taking one example, we explained what is a overcurrent relay, how it can be used to protect any circuit. Now, second definition becomes, what is relay time? What is relay time? It is the time between the instant of fault occurrence, whenever the fault occurs in any system, and instant of closure of relay contacts. These are the relay contacts. These relay contacts will be closed from the fault to closing of the contacts. That is known as relay time. Now the second definition is relay time. The relay time is defined as, it is the time between the instant of fault occurrence and the instant of closure of relay contacts. From the fault occurrence to relay contact when it is closed, that is known as relay time. Now another one is breaker time. Let us discuss. The third one is breaker time. What is circuit breaker? It is a breaker, means it is a circuit breaker. Breaker time is another one. The breaker time is the time between instant of circuit breaker operating. Circuit breaker you can represent like this. It is the time between the instant at which circuit breaker operates and opens the circuit to instant of extinguish the arc. In circuit breaker, arc will be extinguished. All these are completely, that is breaker time. Whenever fault occurs, the relay give the signal to circuit breaker, because circuit breaker trip coil will be connected to relay trip coil like this. The relay contacts are closed, then circuit breaker opens. It is the time between instant of circuit breaker operates and extinguishes the arc. Completely, if you want to understand circuit breakers chapter, you can understand easily. Breaker time means completely closing the circuit, completely opening the circuit from the instant of relay operation to totally when it will completely extinguish the arc, completely disconnecting the circuit. That time is known as breaker time. Breaker time means arc extinguishes between contacts of circuit breaker. Circuit breaker, the chapter, then you can understand in that chapter. The next definition related to protective relays, the fourth one is pickup. What is pickup? What is pickup? Pickup in relays. What is this pickup? A relay is said to be pick up when it moves. Suppose the relay will be in off condition. From off condition to on condition when it reach, that is known as pick up. The relay is said to be pick up when it moves from off position to on position. Off to on position when it reached. Then the relay is said to be in pickup. Pickup means turning on the relay. The relay coil will energized. By CT it is connected. From off position to on position, what is the time it takes? That is pickup. What is the current takes? That is pickup current. Now what is a pickup? A relay said to be pickup when it reached to on position from off position. Under normal condition, the relay will be inoperative. This is the relay and it is connected to circuit breaker. Under normal conditions, the current from the CT. Under normal conditions, the current from CT is, you can see, the CT current is very low under normal working conditions. It is CT. Whenever fault occurs, the relay coil moves the flunger downwards. Then it's said to be pickup. That is off position to on position when it reached. That is known as pickup. Pickup value is, what is the pickup current? Next definition is pickup current. Pickup current. What is pickup current or pickup value? It is the minimum value of actuating quantity, alternating current. Pickup current means it is the minimum value of current at which the relay tries to operate is known as pickup. Next one is pickup current or pickup value. Next, fifth one is pickup value. Pickup, it is very important related to relays. Pickup current or pickup value. Pickup value in the sense, pickup value, it is the minimum operating current. Pickup current means minimum operating current. Pickup value means minimum operating value. It is the minimum value of alternating quantity at which relay starts to operate. It is the minimum value of current or at which the relay tries to operate. Suppose the relay maximum pickup current is 10 amps. Assume that. Below 10 amps, the relay will be inoperative condition. The relay will not operate. The pickup value is 10 amps means more than pickup value or greater than or equal to pickup value, then relay try to operate. That is known as pickup value or pickup current. The pickup value may be 10 amps for overcurrent relay. For impedance Z is 10 ohms, below 10 ohms it will operate. It is the minimum value of current at which the relay tries to operate is known as pickup value. Pickup value, they are mentioned in relay nameplate details. Now you can see it is the minimum current in the relay coil at which the relay tries to operate is known as pickup current. As long as the pickup current is less than pickup value, the relay will not operate. More than pickup current, the relay tries to operate. Now you can see it is the minimum current in the relay coil at which the relay starts to operate. ఆ మినిమం కరెంట్ దగ్గర రిలే ఆపరేట్ అవుతుంది కాబట్టి దాన్ని పికప్ కరెంట్ అంటారు. అంటే రిలే 10 amps అని అజ్యూమ్ చేసుకుంటే బిలో 10 amps ఇట్ వోంట్ ఆపరేట్. అంటే ఈక్వల్ టు 10 amps ఆర్ మోర్ దాన్ 10 amps, greater than 10 amps it will operate. That is known as pickup current. That is the definition of pickup current. Less than the pickup value, the relay does not operate. Equal or greater than pickup value, then the relay tries to operate the circuit breaker. That is known as pickup current. The next one is current setting. The important definition, that is current setting. The next one is current setting. It is very important. Current setting multiplier. Pickup current, how can you obtain? By changing the current setting. The current setting, the pickup value of overcurrent or current can be adjusted to the required level in the relay, which is known as current setting of the relay. current setting of the relay, pickup value, that is pickup value 50%. If you can see, it is a 50%, it is 70% of pickup value, 100%, 125%, like that. There are setting for that. Percentage of current setting, that is plug setting, it is also known as. A pickup value of overcurrent can be adjusted to required level in the relay, which is known as current setting of the relay. The current setting of relay can be achieved by use of tappings on the relay. These are the tappings. The current settings can be achieved. It is often to desirable adjust the pickup current any required value. This is known as current setting, and this is known as current setting, and usually achieved by this type of tappings on the relay operating coil. The taps are brought to plug bridge. It is known as plug bridge. Plug bridge, it is known as plug bridge, as shown in figure. The plug bridge permits to alter the number of turns on the relay coil. When the relay coil number of turns are altered, then pickup current value may be changes. If large number of current turns are there, current turns, then maximum magnetic field will be produced. This changes the torque on the disc. In case of induction relays also, if the number of turns are increased, it produces more magnetic torque, electromagnetic torque, gives rise to pickup current increases, current setting will be increases. The plug bridge permit to alter the number of turns on a relay coil. This changes the torque on the disc, hence the time of operation of relay will be changes. The value assigned to each tap are expressed in terms of percentage of full load rating of current transformer. Full load rating of current transformer, it will be expressed, in which the relay associated with and represented value above which disc rotates and finally closes the trip circuit. There is a definition for that. Pickup current is given by rated secondary of CT into current setting. This formula is important. Pickup current is given by percentage of current setting into rated secondary current of CT. Secondary current of CT. Pickup current is formula, one of the formula. It is the product of rated secondary current of CT into current setting, or we can say that pickup current is calculated from percentage current setting. It is known as percentage current setting into rated secondary current. Okay, one of the important definition and formula related to relays is pickup current. Most of the questions will be like this from the relay definitions. What is pickup current? I am writing here. Pickup current is determined from the plug bridge. Pickup current equal to percentage current setting. Percentage current setting 50%, 75%, like that. Percentage current setting into rated secondary current of CT. Rated secondary current of CT means secondary. What is the rated current? If 1000 amps is there, 50 amps is the rated current, like that. You know that rated current of secondary of CT, that is known as pickup current. Pickup value, how can you determine from plug bridge? It is very important. Percentage current into rated secondary circuit current of CT, or we can represent like this also. Pickup current is given by rated secondary current of CT into current setting. This formula you have to remember. Pickup current equal to rated secondary current of CT into current setting. For a longer time it will be helpful to you. For example, if you consider a relay having current setting 125%, there is a, let us consider for an example what is the pickup current, how to calculate. For example, an overcurrent relay having current setting of 125%. In the plug bridge 50%, 60%, 80%, 25, 50, 75. In terms of 25% they can change, 50%, like that. You can see in the previous diagram, plug bridge it is 50, 25, 75, 100, 125%, like the 25% variance is there. Each plug setting can be changed 125% if the current of the setting of the relay is connected to. Okay, in the plug bridge, each bridge is having 25% variations of current, percentage of current setting value. For example, an overcurrent relay having current setting 125% and is connected to a supply circuit through a current transformer 400 by 5. Rated secondary current of CT is 5 amps here, not for 400. 400 is primary current, 5 amps is the secondary current. The rated secondary current of CT is 5 amperes. Therefore, pickup value will be 25% more than 5 amps. That is 5 into 1.25. What is the pickup current? Pickup current equal to percentage setting of CT, that is 1.25, that is 125%, that is 1.25 into rated secondary current of CT is 5 amps. 125 into 1.25 into 5 gives 6.25 is the amperes of pickup current, 6.25. Okay. The current setting varies from 25% in case of overcurrent relays, whereas the step for earth fault relay case current relays, earth fault relay leakage current relays, that is 10%. Earth leakage current relays ఉంటాయి, అవి 10% చేంజెస్ ఉంటాయి. అంటే each plug is 10% variation ఉంటుంది. That is important. Now we go for plug setting multiplier. That is very important definition and formula. Up to now we know that formula. What is a pickup current? What is a relay? Okay, now we go for PSM, plug setting multiplier. Simply we can say that plug setting multiplier. Now we go for PSM. Now we go for PSM. What is PSM? I told you. Plug setting multiplier of a relay. It is defined as the ratio of actual fault current. It is defined as the ratio. One ratio it is PSM means it is defined as the ratio of actual fault current in the relay coil to pickup current is known as plug setting multiplier. Actual fault current in relay coil, actual fault current in relay coil to pickup current. Simply pickup current formula, you know, pickup current formula is fault current in relay coil, actual fault current in relay coil divided by pickup current is percentage current setting into rated secondary current of CT. Rated secondary current of CT. Already we told what is a plug setting multiplier. Pickup current is obtained from rated secondary current of CT into percentage setting. Okay, simply we can define what is plug setting multiplier. Let us see. Simply we can define plug setting multiplier PSM as it is the ratio of fault current in relay coil to pickup current, that is PSM equal to fault current in relay coil divided by pickup current. What is pickup current? You know, pickup current is defined as rated secondary current of CT into plug setting, percentage current setting, plug setting, that is plug setting multiplier can be obtained. What is the use of plug setting multiplier? You can see now. It is ratio, we have to remember, it is fault current in relay coil to pickup current. Now you can see by substituting fault current in relay coil divided by what is pickup current, that is rated secondary current of CT into current setting. If you substitute, then you can calculate PSM value. For example, in that a relay connected to 400 by 5 current transformer and set by 150% with the primary fault current of 2400 amps. The plug setting multiplier for that, how to calculate? For example, suppose a relay connected to 400 by 5. Already CTs have ratio 400 by 5, 1000 by 5, like that. Secondary current always will be 5. Therefore, relays can easily construct for 5 amps. Okay, pickup value for that is rated secondary current of CT is 5 and current setting is given by 1.5, 7.5 it is. Therefore, fault current in relay coil is 2400 amps if fault current flows. What is the secondary current of CT? The CT is like this. The CT primary current is 400 amps. If it is 5 amps will be secondary current. If it is 2400 amps, that secondary current will be reached to 400. It is a 6 times. 6 times means it is 2400 into 5 by 400. That gives 30 amperes. Fault current in relay coil is given by the fault current is 2400 into CT secondary current is 5 by 400, that is 30 amps. Therefore plug setting multiplier is given by, that is fault current in relay coil. How to calculate fault current in relay coil, that is important. సపోజ్ ఒక రిలే కాయిల్లో ఫాల్ట్ కరెంట్ ఎంత ఉంటుంది అనేది చూద్దాం. ఇప్పుడు ఫాల్ట్ కరెంట్ ఇన్ రిలే కాయిల్, హౌ టు క్యాలిక్యులేట్, డిటర్మైన్ ద ఫాల్ట్ కరెంట్ ఇన్ రిలే కాయిల్. హౌ కెన్ యూ సే దట్ సిటీ సెకండరీ వచ్చి కనెక్ట్ అయి ఉంటుంది కదా రిలే కాయిల్కి, అంటే ప్రైమరీలో ఎంత కరెంట్ పోతే దానికి ప్రపోర్షనేట్గా కరెంటు సెకండరీలో వెళ్తూ ఉంటుంది. ప్రైమరీలో ఎంత కరెంట్ వెళ్తే దానికి ప్రపోర్షనేట్గా సెకండరీలో కరెంట్ వెళ్తూ ఉంటుంది కదా. అంటే మన సిటీ 400/5 ఇట్ ఈస్. ఇఫ్ ప్రైమరీ కరెంట్ ఇంక్రీజ్ టు 2400, వాట్ ఈస్ ద కరెంట్ 5? దట్ ఈస్ 2400 into 5/400. that gives 30 amperes. Four ones are 4 6 are, that is 30 amperes. Therefore plug setting multiplier is given by fault current in relay coil divided by pickup current. Pickup value already we calculated as 7.5, because pickup value formula we have to remember previously what we discussed. Therefore PSM equal to 30/7.5, that is multiplying factor plug setting multiplier is 4 amps. 4 it is, there is no unit for that plug setting multiplier. PSM equal to fault current in relay coil to pickup value. Pickup value current can be calculated by this value. Therefore the plug setting multiplier is 4. What is the use of plug setting multiplier is multiplication factor that can be used for a relay. The next one is time setting multiplier. A relay generally provided with a control to adjust the time of operation. For every relay, the time of operation, if instantaneous means it is 0 time delay, if it has a time delay means 0.4 seconds, like that. This adjustment is known as time setting multiplier. The time setting dial switch is calibrated from 0 to 1 second in terms of 0.05 seconds, that is time setting multiplier. The time of a fault current into time of operation of a relay, you know that from the fault occurrence to the relay trips the circuit breaker, that time is known as relay time. Now this time can be changed, this time can be altered easily by using time setting multiplier. The time setting dial is calibrated from 0 to 1 in steps of 0.05 seconds. These figures are multipliers to be used to convert time derived from PSM curve. PSM curve నుంచి మనకు వచ్చేది టైం సెట్టింగ్ మల్టిప్లైయర్ ఎలా క్యాలిక్యులేట్ చేస్తాం చూస్తాం. ఇక్కడ PSM కర్వ్ అనేది ఒకటి ఇస్తారు మనకు. PSM కర్వ్ ఈ విధంగా ఉంటుంది. Like this a PSM curve will be there. Plug setting multiplier versus operating time in seconds of a relay. For every relay the manufacturer will give this PSM curve. The PSM curve, from that we can say that 6, if it is a PSM, what is the time of operation? Time operating time is 4 seconds. If it is already we calculated 4 PSM, for that time of operation is 6 seconds. Like that a manufacturer will give PSM table to you, PSM graph also. Here one we have to remember that if the time setting is given by, if the time setting is 0.1 will be here, assume that 0.1, it is 0.1. If the time setting is 0.1 and time obtained from the PSM curve is 3 seconds, then actual relay operating time is 3 into 0.1, that is 0.3 seconds it is. That means from the PSM curve into 0.1, that is a plug time setting multiplier. For that instance, induction relays, the time of operation is controlled by adjusting the amount of travel of the disk. We can adjust the time of operation of relay by using time setting multiplier and PSM curve. What is PSM curve? The curve which is drawn between PSM versus operating time of a relay. From that it is also important, plug setting multiplier curve or time setting multiplier curve, it is time TSM curve. It is also known as time setting multiplier means TSM. It is will be multiplier. In induction relays it will be useful. A dial will be there, that is in terms of 0.05 seconds, 0 to 1 second it is calibrated. By adjusting this dial, we can adjust the time of operation of a relay. For example, one example we have to consider what is the time of pickup current, what is the PSM, how to calculate. Let us consider an example. Determine the time of operation of a 5 ampere 3 second overcurrent relay having a current setting of 125% and a time setting multiplier of 0.6. TSM is 0.6. Time setting multiplier is 0.6 connected to a supply circuit through 400 by 5 current transformer through 400 by 5 CT. When the circuit carries a fault current of 4000 amperes, use the curve shown in figure previously what they given. Rated secondary current of CT is 5 amperes. From this current CT, we have to write the given data first. After that, pickup current is given by CT secondary current into plug setting. That is, current settings is given by 1.25. 125% is there. 1.25 we have to collect. 6.25 is the pickup current. Fault current in relay coil is given by 4000 into 5 by 400. That means when CT reaches to 400 amp, secondary current will be 5 amperes. If the CT reaches primary 4000 amperes, secondary current will be 50 amperes. Simply 4000 into 5 by 400, that gives 50 amperes. That gives 50 amperes. After that, PSM is given by, what is the formula? Already we discussed in previously. That is, from PSM is 50 by 6.25. That is fault current in relay coil to pickup current, that is 8 is the PSM. Corresponding to 8 in PSM curve corresponding to 8 is, the operating time is 3.5 seconds. Therefore, the relay operating time is given by 3.5 into time setting. Time setting is given by 0.6. 0.6, that is 2.1 seconds. That is about pickup current. Again, what are the important terms and definitions that will be very important for relay. These are some numerical problems maybe comes in examinations. Next class we go for different types of relay, functional relay types, differential relays and overcurrent relays, earth fault relays, directional power relays, like that the relays are classified. Those are functional relays. Like this you can see. According to the activating quantity, the function relays are according to function. If it is a overcurrent relay, which type it is, induction type, like that. According to functional, the relays according to service they will provide based on operating principle of electromagnetic attraction or induction. Most of the relays are based on power system today operate on the principle of electromagnetic attraction or electromagnetic induction mostly. Regardless of the principle involved, relays generally classified according to function they are called upon. For example, a relay which recognizes an overcurrent, it is known as overcurrent relay. Current greater than which predetermined value, it initiate the correct to, it will be known as overcurrent relay. Overcurrent relay means current is the activating quantity. Irrespective of that, if it is a voltage is the activating quantity, it is known as over voltage relay. Similarly, that distance relays, differential relays, translay scheme, induction type overcurrent relays, induction type reverse power relays, that is direction of the current, direction of fault current can also identified by the relays. How to identify it is very simple. Next class we will go for functional relays, different types, how they are working, induction relays. To understand all this, from the first class onwards you have to prepare. After that you can get easy idea. Okay, thank you.